different with what we have to do. We're going to apply the same transformations we did in the chapter 7 unit that we did in the chapter 1 unit. So we're applying all these things. So I think we should be okay. I'm not sure how you want to tackle this though. I think the first thing is I'm going to say base 4. So if I were to do a base 4 exponential graph, okay, so if I were to do the basic log 4 graph, it's this in exponential form. And it might be helpful, I'm just going to pop over to here for a second, to do, you guys can do this graph. I'm just doing this on a scrap piece of paper just so we can do it really quickly. 4 squared is 16, 4 to the 1 is 4, 1, 1/4, 1/16. If I know this one, do I know this one? Right? It's just the inverse of each other. So what's going to happen to my x and y columns? They're just going to flip, right? Could you have done that from this graph? Or sorry, from this equation, this base? You would pick your y's in this case. We're pretty quiet today. Not the worst thing in the world. Where is the asymptote on this graph? You're on a logarithmic graph. Yeah, x equals 0. Because remember, if it's inverse on an exponential graph, the asymptote was the x-axis, which was y equals 0. So if we're flipping the place of the x and y, your asymptote's going to flip to y equals 0. So we know that we have an asymptote. It's going to be a vertical.
Horizontal.
No. We know with this graph, we're going to have a vertical asymptote. So it's going up, down at x equals 0. Oh, I'm not supposed to graph that one. Never mind. I'm not going to graph that one. Okay, now we're going to do the transformations. So what are the transformations here? And I'm going to put it in a mapping rule because the mapping rule is the actual math I have to do. So what is that telling me? Steve, why don't you take off your jacket?
Because my shirt stinks like coffee grounds.
Oh, okay. So this is going to be 4 units, right? And what's this one telling us to do? Okay, so if I have a vertical asymptote, it is going to be affected by, oh, I'm grabbing purple for purple, that's not really great. So now this, the horizontal shift, is going to affect my asymptote. It's going to have a direct effect on that. So if I'm moving my whole graph 4 units to the right, where's my new asymptote going to be? X equals positive 4, right? You're moving all your x values to the right 4, so that's going to include that asymptote. It was here, and it's going to shuffle over 4 units this way. So now let's do our table of values for that logarithm graph. Ooh, I didn't finish my mapping rule. So the x's we're going to add 4, and the y's we're going to be subtracting 2. I'll do my y's first because they're easy to do. Okay, now we're going to do our x's. And so we're going to add 4 to them. So this is going to be 4 and 1/16, 4 and 1/4, 5, 8, and 20. Just gonna put a box around that just because I'm running into different things there. You guys are really quiet today and it's beginning to worry me. No, nobody else is worried? We're all good? Oh my goodness. All right, let's graph it. We know, like I said, the asymptote is going to shift over. I'm going to go up by 2's on my x-axis. And I'll go up by 1's on my y-axis. So I know that my new asymptote was at 0, and now it's been shifted 4 units to the right. So it's going to be at +4. And if you actually graph the data, it's going to make sense. But I like to put that boundary in just so that I don't cross it, because if I cross it, I'm going to lose marks. So at 4 1/16, so that's really, really close to the line, I'm at -4. And at 4 1/4, which is also really, really close to the line, I'm at -3. At 5, I'm at -2. At 8, I'm at -1. And at 20, I'm at 0. So on this graph, ladies and gentlemen, I should not be crossing that x-axis. Because where would I be crossing the x-axis? I'd be crossing the x-axis like somewhere out here. Because if this is 10, then 20 occurs right there off the page. So when you do this graph, you shouldn't be coming up and crossing the x-axis, because we know it should cross at 20 and 0. So just keep that in mind when you are graphing things. And I graphed it, so I have to label some points. Okay. So nothing too different there. Looks like your chapter 7 stuff. Nothing too terrible, I don't think. You might disagree with me, but I think we're okay. All right, let's do some transformations. We're just describing them. We're going to say what they are. So remember that none of the transformations are affected by what the base number is. Of course, our table of value is. I didn't even pause for that. Everybody knows how I got the table of values, right? Like, because we're base 4. I think putting it sometimes into exponential form is helpful. Okay, what about this one? What's happening here? One unit left, yeah. It is a shift. All right, now this one is a trick question. It's been the trick question for all of these. What do I have to do to untrick it? Common factor that 2 out. So we're going to have log base 3 bracket 2 bracket x minus 5. That has been the trick for like 3 units already. So hopefully we're getting more comfortable with that. So we have a horizontal stretch by a factor of 1/2. And what else do we have?
Horizontal shift 5 units, right?
Yep. I still kind of see us making these, there's so much to remember. Somebody said that to me the other day. There's just so many rules to remember. And I agree. Whoa. That's not what I wanted to happen. and I agree with you, there is a ton of rules. And I wish I could make it easier with remembering all the rules, but somehow it doesn't work that way. Okay, what about this one? Nice and easy. Three units up. Okay, this one has a lot in it. This one has a lot. Okay, let's start from the outside and work our way in. What does the negative tell us? Reflection in the x-axis. Kate, what does the 3 tell us? So we have a vertical stretch. Okay, and you need that by a factor. You need that. Okay, is anything happening with the x in the brackets? No, so we have no shifting left or right. And we are going to go 2 units down. All right, another trick question. Another trick question. This one we haven't seen that much, so I give you a little bit of reprieve if this isn't leaping off the page at you. I'm going to say log base 3. I'm going to switch these around so it's negative x plus 1. If I write it like that, I think we all see it. It's the same trick question that we've seen a million times. So this would be log base 3, negative 1 gets pulled out, x minus 1. So you need to be able to do that. If something is attached to the x, if it's not just a positive x, then there's something you have to common factor out. So this is going to be a reflection where? Yeah. And then we have a horizontal shift, 1 unit to the right. So if you didn't pull that out, you'd get the mark for the reflection, but then you'd lose the mark because your shift would be going in the wrong direction. So if this was a 2-mark question, you would lose a full mark. If it's a 1-mark question, you'd lose half a mark. Okay, there's a lot of things going on next door. Okay, this is the same trick question. I'm not going to rearrange it for you. You guys tell me what it is.
Reflection in x-axis.
I disagree with where, but I agree that it's a
the
reflection.
Reflection y-axis,
Mhm.
horizontal shift 4 units right, and vertical shift 1 unit up.
Shift 4 units to the right and 1 unit, ooh, I can't spell unit up. And if we were to do the factoring, that's what it would look like. Bless you. And the last one I think we can do without changing it. I think we can do that again. So we have a reflection. Ooh, I'm writing right over the number 37. All right, not too terrible. That's the stuff that we did in chapter 7. That's the stuff we did in chapter 1. Nothing too terrible here. All right, I'd like you guys on your own to graph this one. I'm gonna hit pause, I'm gonna hit freeze on the screen. I'll graph it, you're gonna graph it. It's a Monday morning. Anything happening to the Y's on that first graph? Where does your asymptote move to? Two units right, so if it was at x equals 0, it's moved 2 units to the right at x equals 2. Do you reflect or shift first? Reflect. The order of operations, right? We're going to do any multiplying first, and then we'll add or subtract. I don't know if that helps you, if it makes you want to cry, I'm not sure. It'd be super handy if you tried it. If it's a Monday morning and you're just waiting for me to do it, that's okay too. I can only imagine watching this video later because I'm not trying to keep it straight for the screen. Am I good to show you this graph, or do you guys need another minute? You need another minute? No, you're good? You're just waiting on me? We were reflecting in the y-axis, so we should expect that our data is going to be on the left-hand side of the asymptote. Because without a reflection, it's usually on the right-hand side. I think I did my math right. It's a Monday for everybody. Okay. All right. You guys don't seem very excited this morning. This is weird. Nobody's talking. Nobody's being kind to one another. It's just flat today. It's weird.
You need Joan back.
Always. Always.
If you choose graph or one.
Pardon? You want to see that graph again? Okay. Okay, next graph. It has a base 2 on the log. So when I go to do my table of values, I have x equals base 2 to the exponent y. So all this is this logarithm graph, the basic logarithm graph here. Okay, these two things are the same thing. The inverse and the log graph are the same thing. This one just doesn't have any transformations in it yet. So if I'm looking at this, I'm making up the y values. And if it's a base 2, nice and easy. Now I'm going to apply my transformations. I'm going to apply my transformations. So I am adding 1 to the x's, and I'm adding 3 to the y's. So adding 1 here, so this would be 1 1/4. I like using the whole, like a mixed fraction here. If you want to use improper, you wouldn't be wrong. If you want to use decimals, you wouldn't be wrong. I just like either adding or subtracting whole numbers there. Okay, so I'm supposed to add 3's here. So 1, 2, 3, 4, 5. What happened to my asymptote?
Plus 3.
Plus 1, yeah. So that's what you got to remember. Exponential functions, it's a horizontal asymptote, so it's going to be affected by the vertical shifts. Logarithm graphs, the asymptote is vertical, so it's going to be affected by the horizontal shifts. And these are things you got to remember. Your table of values will kind of lead you to it, but if you can kind of remember that, that's going to be helpful. We don't have any reflections, so I anticipate all my data being to the right of the asymptote. And again, you do not have to draw in the asymptote, but you do have to have asymptotic behavior. Again, if you're drawing it, you do need 2 points on it. So please make sure that it's there. I find the table of values super helpful when I'm graphing these things. But it's really how you prefer to do it. Some people are good at doing translation of points, or you know your basic graphs, so you can just shift over and plot the point in your head. I am not that person. I need my table of values to graph my coordinate pairs. That's just works for my brain. Okay, the next one has a lot of transformations. I have written that you're going to do them all on your own. So I'm going to get you guys to do this one all on your own. We're going to skip the last one because if you can do this one, then you'll be able to do the second one on this page. And I want to move into creating equations because that is required in pretty much any function that we're dealing with. That's required. You need to know how to create the equation. A mapping rule might be helpful for this one. This is a trick question as well. Not very tricky when I tell you it's a trick question. Those are some ugly fractions. Where did your asymptote move to? What kind of one? -1, right? Because we were going to the left this time. What side do you anticipate the data to be on of the asymptote? The right or left side? Okay, better question. Where are you reflecting, in the X or Y axis? X axis. So before, logarithmic functions were an overhand throw. What do we anticipate this time? An underhand throw, right? Ooh, what? I can't hear you. You're like mumbling. I don't know what you're saying to me. Confirmation of what? Do you guys want to see my table of values? Would that be helpful for you? Because they're ugly fractions. Really, you just got to know it's really, really close to -1. And then it's kind of close to -1. Right? Like, Like, am I ever gonna check to see that it's exactly 27th, negative 26 over 27? No, we're looking for just that trend. I might not even plot this point just because it's so close to the line. I have 3 points. Oh, maybe I should do it on this side. I have 3 points between the increment of 0 and negative 1. I have 3 points. That's going to be really tough to fit them into that little thing, but you get the idea of what the data is doing. How many people felt confident in this? I didn't when I was doing it. Like, I really took me a second. Like, okay, negative first, then I'm subtracting 1. Fractions always shake our confidence for sure. But did you get your asymptote in the right place? At negative 1. Did everybody get their asymptote at negative 1? Okay, Steve.
I'm still doing my
Yeah, that one was definitely ugly. But if you can do this one, you can really tackle anything. Yep.
Did you plot the fractions, or did you just apply like asymptotic?
I more went with a feeling on this one. I probably would lay down my x-intercept, because that's a really important point, like that then negative 0.6 repeating. And then I just do asymptotic behavior from there. And I will never probably label a fractional coordinate pair unless it's absolutely necessary.
Okay, so for the mapping rule,
Mm-hmm.
you do the stretches and squishes first, and you do the addition and subtraction.
Right. Yep. Yep.
Okay, so it would be 1/3 times x, and you subtract 1.
Right. And I'm going to do everything to my x's first, right? Like I'm going to just work on my x's. So that 1/9 becomes 1/27. And then I'm subtracting 1 from it, so I'm going to have negative 26 over 27. And all I need to know is that's really, 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 really extremely close to that negative 1. And like people said, are you actually graphing these, or are you just doing asymptotic behavior? I think I would definitely lay down my x-intercept because it's given. And I think I just do kind of the asymptotic behavior. I just kind of let that curve just go. Because as long as I have 2 points that are labeled and I'm following through and the behavior. Now, it would be a problem if my x crossed at 0 or it crossed into the positive. Like it definitely has to be, it has to follow what your data is saying here. Just because I'm not graphing these points doesn't mean my data doesn't have to follow that. Like if this didn't cross in the negative, and if it has to cross closer to the negative 1 than it does the 0. Okay, that one was nice and ugly. Not impossible, but definitely ugly. Okay, I'm flipping the page. Yep.
Today is like the class semester in the past 3 years.
I've said that already today. Why are you repeating what I'm saying? Just to say stuff? That's fair. We need to fill the airspace. Okay, I'm going to tell you guys that usually you're going to get either a vertical stretch or a horizontal stretch. It's unlikely you would get both on one of these questions. Do they happen both? Absolutely. Are we gonna give you something that is, and by we, I mean me, am I going to give you something that is absolutely terrible? Probably not, just because these get a little bit complicated quickly. Okay. So let's look at this first graph here. Do we see, and if dots are given, those points are translated. So this point translates to that point. And we know that this is our original one. Let me get a highlighter. I had a highlighter. This graph here is our graph with no transformations on it. It's labeled. It's helpful. If you don't have that, put it on, right? It would be hard to do this question because you wouldn't know what base to start with. So we know we have a logarithm with a base 4. We know that when x is 4, the y is 1. So we know that we've got this base log, or log base 4. All right. Are there any reflections? Let's talk about that. No, it's not. It's like, this is what I call an overhand throw, like you're throwing it overhand. If it was a reflection in the x-axis, you'd be throwing it underhand, like it'd be scooping. Instead of throwing, it would be. So no reflection in the x-axis, definitely no reflection in the y-axis, because then that would be on the other side of the asymptote. Any horizontal shifts? And how would I know if there's a horizontal shift?
Shifting of the asymptote.
The asymptote would shift. So if the asymptote is shift, that is a key point that you would know that you have a horizontal shift. So asymptotes on log graphs are affected by horizontal shifts. They're both following the y equals 0, so I know I have no horizontal shift. Do I have any y shift? How do I know that? What do I know about these 2 points? They're translated, right?
And they have the same y value.
They have the same y values. So what can I be certain of? Nothing's happening to the y's, right? Nothing's happening to the y's. Because if it was times by a -1, the whole graph would change, and we'd recognize that. So there's no change to the y's. No change to y values. And you told me that my asymptote didn't shift. So really, what do I know I have here? I know I have a horizontal stretch. So I know that there is a horizontal stretch here. There's no change to the y values. Okay, so if the original graph was 4, 1, and the new graph is 1, 1, so we have 4, 1 translating to 1, 1, and we know it has to be a horizontal stretch. What do I have to multiply 4 by to get it to 1?
1/4.
1/4. So when we put that into our equation, what's the value going to be?
X divided by 4. I mean,
No.
4x.
4x, yes. So log base 4 and then 4x. I'm going to just put brackets around that just to remind myself that that's all attached together. So there was some thinking I had to do before I could do anything with the actual transformations. Okay, next graph. We were an overhand throw, now we're an underhand throw. So what happened? A reflection where? X-axis. Let me get my handy dandy highlighter again. So that's my original. And this point translated to that point. Is there a horizontal shift? No, we know there's no horizontal shift because they're still both functioning on that asymptote of y equals 0. Now, is there a vertical shift? And I would disagree with you. I want you to look at the shape of these two graphs. If it is just a shift, the graphs would look exactly the same. I also know there's not a vertical shift because of this point right here. What is that point? 1, 0? Everybody would agree with me, 1, 0? If there was a shift, so 1, 0 translates to 1, 0. If there was a shift, it would affect when y equals to 0. It doesn't affect. It's the only thing we can do is multiply. Anything multiplied by a 0 will stay a 0. If we shifted 4, that point would also shift down by 4. Got it? So you guys are telling me there's a shift of 4 down. That's where your heart and soul is right now? No? So shape of the graph tells me it's not, but also if I look at a point that has a y value of 0, that would be the place that we would see the shift. Because no stretch would affect it. So what I know is that this has to be a vertical . This has to be a vertical stretch. Yep. So if this point was 4, 1, and it translates to 4, -3, we already know that our y values are going to be times by a negative. So we already knew that was going to happen. But what do I have to multiply 1 by to get it to change to a 3? 3, right, everybody? Yes. And 1 times by what gives me -3 is going to be -3. So my equation would be y equals -3 log base 4 argument x. All right. Good times. Okay, this one's super easy. What's the base on the log? Yep.
On those transformation questions, will there only ever be one transformation?
There might be a shift and a stretch, but there won't be 2 stretches. Like there won't be a horizontal and a vertical. What's the base on the log? Let's go back to that. What's the base on the log?
1.
Right? It's an invisible 10 for the very first time in your mathematical career. Logs, if no base is stated, it's a base 10. What's the name for that? Do you guys remember? I wasn't even here to teach it to you, and I'm asking you all these difficult questions. Called a common log. Will that ever be a question? No. But I just wanted to say it. Okay, welders wear helmets to filter out light to protect their eyes. If you've ever welded something, you know how bright it is. The filter shade number N is defined by the function given here, where T is the fraction of visible light that passes through the filter.
It's not light, it's radiation.
Shut up.
And how does radiation present itself in this case with welding? What do you see?
Light.
Light. Okay. So
Shut up.
where are we? Is that going to be impactful to this question? Because it does mention radiation and light in this question. Why do you wear filters in your welding helmet?
Partly light.
To protect your eyes, right? Yep. Okay. So N is defined, so N's the filter shade. The different things that you are going to weld will require different shades of protection. And T is the fraction of visible light that passes through the filter, because obviously you don't want it blacked out. Shades range from 2 to 14, with a lens shade number of 14 allowing the least amount of heat or light through. So 14 is your darkest, 2 is your lightest. Correct filter shade depends on what type of welding. Shade number 12 is suggested for arc welding. Just in case you're looking at doing something after school, use a shade number 12 if you're arc welding. What fraction of light passed through the filter to a welder as a percent to the nearest 10,000th if you're arc welding and using a shade 12? Okay, what do we know? What do we know? What information do we have if we know we're using shade 12?
T equals to 12.
Nope. N equals to 12. N is the number, right? N is the number shade. So we're going to fill in what we know. We've got 12 equals 7 minus log T over 3. What are we trying to solve for? We're trying to solve for T. That's what we're trying to look for. We're trying to look for the percentage of light that's being let in. Ooh, sorry, +1, thank you. What am I going to do now?
Murder the one.
I'm going to get rid of the 1, right? I'm going to get rid of the 1. So I'm going to have 11 equals 7 minus log T over 3. What happens next? Multiply by 3. What happens next? Divide by 7. You guys should really come teach my grade 9s. I'm going to leave this as 33 over 7. What happens next? Divide, but yeah, multiply both sides by -1. That'll work. So we have -33 over 7 equals log T. And you're like, I don't know where to go from here. What's the invisible base on this? 10. So we're going to now put this into exponential form. So this is the handiness of being able to go back and forth between exponential and logarithmic. So base of 10, because it's the invisible base on that. This is your exponent, so that's -33 over 7, and that equals T. I need a calculator, which I've lost. Found. 10 to the exponent, -33 divided by 7. Okay. I get this really wonky number here. This is given to me in scientific notation. If it's a -5, this is saying times 10 to the -5. I'm moving the decimal place. If it's negative, 5 units to the left, 5 place values to the left. If it was positive, I'd be moving the decimal to the right, right? Negative numbers on the left of a number line. So 1, 2, 3, 4 zeros, then a 1, 9, 3, 0, 6, 9, 7, 7, 2, 9. And it says as a percentage. So how do I change that to a percent? How do we change any decimal to a percent? How many do I do that to? So I'm going to times it by 100 to get it into a percent, which moves my decimal place because it's positive 2 places to the right. So T is going to be equal to there's 10,000. So tens, hundreds, thousands, 10,000. So 4th decimal place. And I need my percent symbol, and there you go. So that's just a little bit of light that gets through, a little bit. So it's a very, very dark shade. And now you know what welders do.